Okay, so let's do that. Okay. Now, if you remember, we had this concept of expected value, right? Again, this is just what expected value is. We've seen it before. Someone typed something there. Oh, what was that say? Oh, okay. Okay, so expected value, okay? Again, this is just average gain or loss, of an event, assuming there's money involved and the procedure is repeated many times. I mean, for us, expected value will only involve, will only involve, outcomes where money is involved, like gambling and stuff, okay? Where you can either gain or lose money. And again, it's how much you would expect to gain in the long run, or the average gain or loss, if you were to repeat the procedure many times. And we saw how to calculate this actually. Basically, we take each outcome, right? Which is how much money you basically would lose or gain, times the probability of that outcome. And then you add up the products. And if it's negative, you're going to lose in the long run. If it's positive, you're going to win in the long run. And if it's zero, the expected value, we say the game is fair. Okay, that's what we get. And generally, you only want to play a game. Excuse me, you don't want to play a game if the expected value is negative. If it's positive, then you do. I mean, sometimes you're going to win, sometimes you're going to lose, but the expected value tells you overall how much you're going to gain or lose. Let's say we have this one. This actually came from the book. What the? Oh, I got nervous. I thought I lost the slide by mistake. So basically, let's say we have this game. This actually came from the book. So a friend has a game where you roll a six-sided die, a fair one, once. If you roll a 6, he pays you $3. If you roll a 5, he pays you nothing, okay? Now, if you roll less than a 5, you pay him $1. What would the expected value for the game be, okay? When we say outcome, we generally mean money outcome, how much you win or how much you lose. I don't think I said that here. When I say outcome here, I basically mean how much you're going to win or lose. That's what we mean, like money outcome. Maybe that's better. Okay. So if you roll a 6, right, the problem says you gain $3. Now, this is your expected value. So this is from your point of view. You gain $3. But how likely is that? Well, how likely is it that you'll roll a 6? 1 over 6, that's probability, okay? Probability is 1 over 6. You can roll a 5, then you get nothing. That also has probability 1 over 6. Now, you could roll a 1, a 2, a 3, or a 4. Each of those outcomes are -1, right? Because you lose $1. So for each of those probabilities, each of those is equal to 1 over 6. So what's the expected value? Again, you do the outcome times the probability for each one, as you can see. So you have 1 over 6 times 3 plus 1 over 6 times 0, 1 over 6 times -1, 1 over 6 times -1, 1 over 6 times -1, 1 over 6 times -1. We add all these up, and if you do that, you end up getting -0.33. So in other words, the expected value after rounding is -33 cents. Now, negative, what does that tell you? That really you should not play this game. You're going to lose money in the long run. I mean, sometimes if you play, you might win. You might roll a 6 and gain money. But overall, you're going to lose money in the long run. All right, cool. Okay, does that make sense? That is, what questions do you have? Okay. Here I made a slight variation. Namely, if you roll a 6, instead of winning $3, you win $5. So I increased this outcome. Everything else is the same though. What would the probability here be? Well, so the only difference now is that basically where we had $3, we replaced that with 5. So now if you go through the same calculation, $5 times 1 over 6 plus 0 times 1 over 6, and then so on and so forth, -1 times the 6, -1 times the 6, and so on. Here you're actually going to gain 33 cents. So in this case, you really should play the game, theoretically, because you'll win in the long run. I mean, sometimes you might lose, sometimes you might win, but you'll win in the long run. Are there any questions on this? Okay. This one, I mean, I'm not sure if I'll finish this, but I'll try. So here we have a company, and it estimates that about 0.7% of their products will fail after the original warranty, but within 2 years of their purchase. And the replacement cost will be $350. Okay? That's how much it will cost to fix it once it fails. Now, let's suppose the company decided then to offer a 2-year warranty for $48. Okay, so that means within 2 years, okay, they will cover, the company that is, the company will cover the cost of fixing it, the replacement cost. That's what a warranty does. The customer, it won't cost them anything except buying the warranty, but the replacement cost, the company will cover. So what would the company's expected value be for each warranty sold? Well, there's really only 2 outcomes here, right, that we care about. The product failing during the warranty, which is within 2 years of purchase, and the product not failing then, and the product not failing within 2 years of purchase. Those are the only 2 outcomes that we actually care about. Well, if the product breaks down or fails, in other words, within 2 years of purchase, right? Or the product does not fail within 2 years after purchase. It's one or the other. The complements that is. Well, how likely will it be that they'll fail within 2 years? Well, that's what the 0.7% is. That's a probability. Okay? I mean, what I do is I like to convert it to a number, to a decimal, which is 0.007, which is the same as 7 over 1,000. So that would be the probability that the product breaks down within 2 years. So that's how likely this will happen. And if it does happen, what's it going to cost for the company? Remember, we're looking at the company's expected value. So we're doing this from their point of view. Well, they get $48 for the warranty, but they have to pay $350, right? They cover the cost. So for them, they'll get negative $302. Okay? So it'll be negative $302. That will be their money outcome, so to say. Now, if it does not, however, fail within 2 years, right? Well, that's essentially the complement of this. If this event doesn't happen, then this has to happen. So we do 1 minus this, which is this here. And what if that happens? Well, they get the money for the warranty, but they don't have to cover the replacement cost because it didn't break down. So they gain $48. And then by the expected value, you multiply the probability times the money outcome, which in this case is here, as you can see. And the company, their expected value is $45.55. So they would expect a gain in the long run. Okay, now I know I went through that kind of quick, so I might go through that again next time.